So, hello and welcome to today's Cloud Canaries webinar. Today, we're talking about tackling IT operations complexity with OpenTelemetry, Agentic AI, and observability. My name is Helen Beale. I'm your host today, and I'm joined by Mark Callahan, who is our CEO at Cloud Canaries. Do you want to say hi, Mark?
Good morning. Good morning, everyone, or good afternoon,
Or
depending
good
on
afternoon or good evening,
a good
wherever you are
evening.
in the
Yeah,
world. Yeah,
excited.
perfect. And Cindy Tingle as well, we have here. Cindy, would you like to introduce yourself?
Hi, everybody. Great to see you all. I'm acting a VP of Sales and Chief of Staff here. Excited to be in my first presentation with Mark on tackling IT operations complexity with open telemetry, agentic AI, and observability.
Absolutely, because as we know, IT operations is now unprecedentedly complex thanks to cloud and microservices and all these native modern technologies that we have. Most organizations that we're working with, or most enterprises, rely on several cloud platforms, so your AWS, your Azure, your GCP, and these introduce really diverse and challenging monitoring and troubleshooting requirements. So OpenTelemetry has been really helpful as an open source observability framework, and that emerged as an industry standard for gathering telemetry data across cloud native environments. I've seen the uptake of OpenTelemetry is like nothing else I've seen in my 3 decade long career in technology. It's just been, it's become the de facto standard table stakes so quickly. And this all highlights a critical challenge that our traditional monitoring is falling way short of providing the granularity that we need to manage these modern systems. Added to all of this, we've got new AI coming through. So, of course, Gen AI and the emergence of ChatGPT, or the launch of ChatGPT, has really got us looking in that direction. But more importantly, we've got new AI agents as well that are helping us to do things in such incredibly intelligent ways that we haven't been able to do before. So today, Mark, Cindy, and I, we're going to show you how to quickly implement advanced intelligent agents in your environment and get them to work immediately. We're going to show you how to ensure that your implementation supports your security and risk policies. And we'll explain why agentic AI approaches save vast amounts of time and money and help you deliver on your service level agreements. So Mark does have a few slides to go through today. We also want to make this really interactive, so you can all chat with us and ask questions. There's a Q&A button, or you can use the general chat. But let's start, Mark, by having a look at the agenda. I'll talk through that, and then let's have a discussion about what we mean when we talk about agentic AI. So if you could flip to the agenda slide, that'd be great.
Will?
So I'll talk through the agenda. So we've just done the introductions. We're going to talk about agentic AI in a moment, what it is and how Cloud Canaries fit in, and then we'll talk about how observability ties into that. We'll look beyond what we're doing at the moment and how to use agentic to go better and faster, and then we'll talk a bit more about what the Canary agents are and how they're built, the options that you could do with them, and how to use them to continuously improve and learn, and then sort of post observability, what to do there as well. So Mark, start us off. What is agentic AI and what are AI agents?
Well, I have a slide, and I'm going to actually go over that. Actually, it's one of our next slides. So I've been a good boy. There's only like 10 slides here, so I'll try to go through it. Cloud Canaries are agentic AI, and so what is agentic AI? And so that's kind of built into this this particular slide. They're independent agents that monitor, observe, manage, remediate cloud environments. Now that's the Cloud Canaries aspect. At a higher level, they use workload data and telemetry data. They're based upon really 4 concepts: perception, i.e., this is where they get the workload data and open telemetry data. Reasoning, and that's why we have a neural network for these agentic canaries. Actions, so they can take actions. They can fix things. And learning, the key here, I think the key in agentic AI in general, is that these are learning AI agents. And so it's very important that our agents are able to learn. Also with that, you have to manage them somehow. And so we have this observability dashboard and workflow dashboard that dashboards that can be used to manage your agents that are running your cloud. And the key here, the other key here is it's a single platform. So all this combined within a single platform.
So agents do something. So they're different from our traditional AI, which was like clever automation. They're different from generative AI, which was creating images and text that looked like a human might have done it. These are quite clever things, behaving a bit like a human. They're able to, as you say, reason and learn as well.
I sometimes joke during presentation that they're smart, they're chatty, and they never die actually because they're continually monitoring.
They're
So,
immortal.
um, so the features, and these are pretty much key, continuous monitoring, kind of looking at the compliance aspects for your cloud, broad surface area, and which means these agents can do a lot of different things, much more than what you might find in traditional monitoring or observability platforms. This is post observability. If you boil it down, a lot of it has to do with alarms, notifying, generating forecasts, predicting, and actually fixing things. And there's probably a gradient here that as those agents learn, they do more things. They can predict more events. They can fix more things. So that's pretty critical. At the end of the day, how does this help? And here improves productivity. It reduces cost. It allows us humans to make better informed decisions from a business perspective. And the number one thing, it makes customers happier, it improves their experience, it reduces downtime. It allows them to really exploit why they went to the cloud in the first place.
Let's talk a minute about this then, the evolution of observability. I love that term you just used, beyond observability. So we started with basic kind of system monitoring on servers a really long time ago. And then we got to a point where there was loads of monitoring everywhere and cloud started to appear. And this thing called observability came around, what, I don't know, 5 years ago, we started using the term in earnest. So what was observability, Mark, in your view, in that iteration?
Well, there's a lot of discussion about what it is, and there's a set of pillars that the original definition came out of from IBM, being able to do traces within the applications, to be able to uh, uh, read log files and analyze log files, to also to be able to look at and generate metrics. And so those are the three pillars that folks talked about as far as observability. Now, as time went on, there were a few more pillars added, and now we like to think we kind of take them away, or at least we don't have to. We don't have to. We can expand beyond that. So the key there is from a monitoring perspective. You basically monitor it, and something breaks, you go and fix it. With observability, the goal is to identify issues beforehand and try to resolve them, or be at a point where you can resolve them very, very quickly because you know what the problem is.
And the traces were really important, weren't they? Because that really signified what was different, in that we had these distributed systems in the cloud. So that was really different, that kind of federation, and that what you were just talking about in terms of knowing what the problem was, that became increasingly more difficult. So this idea of the unknown unknowns was happening quite a lot. So we saw this rise in observability. So in your view, which came first, open telemetry or observability? And how do the two compare, contrast, collaborate?
Well, I would say observability came first, but the key here was everyone had a different way to collect telemetry. And there have been many startups that did things completely, well, different. And so OpenTelemetry, the goal there was to unify the way that this information is collected, because it's pretty complicated at collecting this information, and there's a lot of it. So that if you have multiple solutions, that kind of border on observability or observability solutions, you would actually have really complex situations where you're collecting data in different ways, and then you're trying to analyze that data. So OpenTelemetry tried to level the playing field, and it's done an amazing job at that. So what that simply means is anyone who has any enterprise that has compatible OpenTelemetry applications, we can have canaries that actually extract the information that they think they need in a very easy way. Or another system can do the exact same thing. So it levels the playing field and ultimately reduces cost.
And then building on that, around the same sort of time, maybe a bit pre observability and OpenTelemetry, we saw the emergence of another kind of iteration, if you like, of DevOps. So DevOps spawned lots of other ops things like chat ops, and I'm thinking particularly of AI ops. So we saw Gartner, I can't remember what year, I don't know, 2015 or something, start talking about AI ops in terms of us taking multiple data sources from our multiple monitoring tools and using algorithmic AI on top of it to make sense of what was being seen. So look for patterns and anomalies and help us get to the bottom of these problems in these very complex distributed systems that are causing our IT ops people so much pain. So where is IT ops in your view? I know we've seen a lot of consolidation in the industry. So we've seen, for example, Moogsoft being bought by Dell. We've seen a lot of the big players integrate AI ops as almost like a feature into their platforms rather than a platform on its own. So where is AI ops in your view, Mark?
So it is part of the DevOps puzzle, and it's a big piece of it, because at some level, it's very similar to the broader situation. You want to observe how models are created, what tools you're using, tools that you're using that are generating these models, and you want to make sure that the data that goes into ingested by these tool sets to generate the models, which generates the forecasted events, is correct. Because if the data is wrong or not properly cataloged, it's going to be a failure. So that becomes a big focus to actually get good forecasts. And so it's, data is the key. And then the next piece is to actually have those ML tool sets that generate the models, that generate the forecasts, working correctly. And there's a whole kind of effort around ML flow. I don't know if any, well, I'm sure some of you know this, but actually to create a process for generating models and for forecasting. So it's part of it, but it's really focused on data and how the models are being created.
So this is what you're explaining is the difference now between AI ops and AI agents. So why don't we talk about Cloud Canaries if we go to the next slide and talk about how this fits in with what's possible today with agentic AI?
So now let's go through the slide here. And what Cloud Canaries brings is really three changes in the market. And some of them are demanded by the customers, and some of them are just there because of the technology and the evolution. And one is low cost, where you can build a canary, or let's call it an agent, AI agent, at a fairly low cost. You can deploy it. It can, since it communicates, since it senses, since it can reason through our neural networks, it can actually just work with an application. It can work with an observability solution. It kind of sits above it and makes decisions. So there's that aspect. And then agentic AI in itself is really kind of a discussion about the evolution of an AI agent to something more than just answering questions. And, my kind of thought is ultimately the actual code, the template that you use to create or deploy for an AI agent is actually the same. The key here is what is the opportunity for these agents to learn and make decisions on their independently to do things, whether that in the cloud, whether that is rescaling a platform that's being, needs more resources, looking for vulnerabilities, making corrections. All these things require more learning. And I think that is the key with agentic AI, is that it creates a framework and a process on how these agents go from grade school to high school to a postdoc. And I know this sounds pretty crazy, but I mean, the key here is having these AI agents actually make decisions in a way that helps customers and helps the ability of the cloud provider to maintain quality, to scale rapidly, to keep costs low. So, so to me, the learning is the key aspect when you go through these different layers about what is agentic AI.
So if I'm in the audience and I'm working for a large global enterprise in the IT operations teams, and we've already got 14 monitoring systems, and yeah, they're not really giving us what we want, but there's a lot of money that we've invested in them. Do I really have to learn something new and add something new in? And then my second question is, well, if that's the case, is there an opportunity to remove some of the other things that I've implemented? And what's the process that I'd go through to identify whether I could do that?
So with agents in particular, and well, Cloud Canary agents, is that you have a dashboard and you can deploy them. So they can basically, I don't want to say, well, I want to say take over other solutions and basically collect their information, present it in a high level dashboard for the DevOps folks to actually make decisions on or to watch. Or in some cases, replace some of the functionality that a particular solution has. But at the end of the day, all these other dashboards kind of roll into a dashboard that has all these different solutions. So I think it makes it easier. One of the problems with existing solutions today, I'm speaking about observability, is that the costs go up as you kind of roll the functionality out to your enterprise. And at some point in time, it's just very expensive or too expensive. And so this is another area that you can deploy canaries or agents to actually do a lot of this work. And take advantage of OpenTelemetry, take advantage of other solutions that are already deployed, since they can communicate through API calls. So I think that's actually really cool. Ultimately, the goal here is to provide one dashboard for operating a customer's own cloud. So it's not so much for providers of clouds, AWS, Google, who they can certainly use it, but it's really for the customer-facing side who have complex environments, who want to have something else there to monitor their solutions, to actually make decisions in a very short time frame, and provide an interface so that teams can look at what's going on.
So it's perfect if you've actually got a hybrid cloud environment, if you've got a mix of public and private cloud, and it's not just for availability, observations around incident management, problem management and downtime, but also for security and risk. It was interesting though, you used the word take over, and this was one of the things that we were going to talk about today, was how to use this technology to manage your security and risk. But I think if we went to the next slide, it would be good just to dive down a bit deeper into what we were talking about as well, as in terms of like, what's the uplift to adopt this? Do you want to talk us through this?
Sure. So this slide, I'll show you a couple of slides that show workflows, but this is kind of a one-way workflow. The key with AI agents, in particular Cloud Canaries, is that you can deploy them within minutes. So you can get shared canaries that are basically templates that you put in your environmental variables and just deploy them. You can write your own canaries and enter the environmental variables and launch them. But you can launch these very, very quickly, and they can either be launched as executables within your environment or outside, or they can run in a Kubernetes cluster, wherever you want. When they're running, they immediately start to produce data, whether it's OpenTelemetry, whether it's workload data, or all the above. And with that data, you can then make the next step of what set of ML tools, AI tools, has my organization, what do they use? Do they use Databricks? Do they have their own in-house neural networks? Or they use Snowflake and they use Snowflake's Cortex. Basically, it doesn't matter with us. You pick what you think is best for your business and where you are within that business. So you collect the tools, and then you use this data to actually begin to generate models and forecasts. Since we continually monitor, collect data, they run all the time, we can actually use actual data to actually validate our forecasts. So there's a loop that you can look at, quality of the data, the quality of that creating the model, and also the confidence level that you have within the forecast itself and the events that it's producing, because you have actual data. Did an event actually happen? And you can also look at it visually. So you have that. And then with that information, with Agentic AI, Canaries learn. And they can, if they missed an event, they won't miss it the next time. Well, that's, the goal, certainly. And with that information, then these agents can, they can notify, hey, there's a problem, they can act. Well, it's already fixed. We told you about it, but it's already fixed. And go from there. So that's the life cycle of kind of the kickoff from creating one canary to a steady state.
Let's talk about the models a little bit more. And I'm by no means an AI expert, but I understand that there are like model marketplaces, and particularly from some of the cloud vendors. So will people need to get the skills to write their own models, or can they download models from the major cloud vendors, or is there a Cloud Canaries community that provides this sort of thing?
So all the above. There are definitely different sets of tools that should be used by different groups of people, individuals, engineers, DevOps. Databricks is certainly a standard, but it certainly takes some time to learn how to use. There are other tool sets that are pretty easy, as long as your data has been cataloged and of good quality. So you can do it pretty easily. I look at it as an 80-20. So there's, get 80% of the quality out of a forecast. There are a lot of tool sets to do it. If you really want to go beyond that, then you're going to either be customizing your own neural network or using a more complex set of tools such as Databricks, and go from there. So so that's the data aspect of it. As far as our own internal canaries can be shareable. So someone can write a canary and they can share it within their organization or outside of their organization. And when I say share a canary, what it is actually sharing a template. We're not sharing, anyone's data, but we're sharing the basic code template that is used as the foundation to collect that data and actually then implement forecasts and actually respond to events. So that is out there, and anyone who is using our production system can actually go and load a shared canary, or take something that they've written and share it. My theory is 80% of all Canaries, or for that matter, AI agents that manage the cloud, are going to be basically open source. They're going to be very similar whether you run them in AWS or um, Google or Azure or OCI, Oracle. And so they're all kind of like the same. You might want to modify them a little bit to get your particular focus in on your particular environment, your enterprise. And then the last 20% are going to be really more, there's going to be some IP that you're going to want to protect. They're not going to be shareable.
Yes, it'll be something that's really unique to your business rather than generic, like with a lot of web development. So let's go to the next slide, because you mentioned Databricks. I'd love to hear more about the Snowflake element and the neural profit element on here as well.
One of the things that I've talked about in the past is that we're at a point where ML/AI tools are readily available, and they've been around the block a few times, and so that they all seem to be very good quality, and they do work when you provide the correct data. So I don't want to say it's commoditized, but I'm going to say it's commoditized. So whatever you pick, it's probably going to be something that will be useful. You might want to, as you reach that 80%, you might want to do something else that pushes you above that so that you can be more competitive within your marketplace. So for Cloud Canaries, we have the ability, if you are using Databricks, we can, we can connect with Databricks. We can store or canary data within their data lake and generate models that you can then use for forecasting. We can do the same thing for Snowflake. Store data within their data warehouse. It gets loaded into their data lake, or there are all these different names, but their data lake can actually generate a model and look at the forecasting. Matter of fact, a lot of customers use Snowflake and actually Databricks together. So that creates this huge kind of opportunity from a Cloud Canaries perspective that we can use whatever the customer is using. We have our own proprietary, it's not proprietary, but we have our own neural network, and it's neural profit, and we've used that for generating our own models and generating our own forecasting as a default. So if you don't have Snowflake or Databricks, you can use our neural network to actually do that at a very low cost.
We do have sorry to interrupt.
No, the key is what drives this is the data. Is it the right data? Is there governance, and is the quality of that data good?
So we do have a couple of questions from the audience. We have one in the chat from Charlie, and Charlie's saying, just to clarify, the reasoning, learning, and acting that your Cloud Canary will do depends on your customer adding off-the-shelf AI to it.
So we use the tools to build neural networks, and that's really where the learning takes place. And there's certainly feedback into those neural networks that there's learning generated there that we save. So that is the key, and our position is that off-the-shelf tool sets are getting to a point, are already there to actually build these neural networks to actually allow agents to learn.
So how much of it is self-contained within Cloud Canaries, and how much demands a customer to connect to other tooling?
So as a default, we have our own neural network. They don't need to connect with anything. They can build models using our neural network. And it's a serial learning neural network. So customers can use that and not use anything from anyone else. So that's perfectly fine. We just wanted to create the opportunity because there's a lot of enterprises that use Databricks. There's a lot of enterprises that use Snowflakes, Snowflake, that it makes sense to provide this instead of training another group of folks in AI ops to maintain it. Here, it's just what you've been using before, and they're all certainly of good quality that won't make that much of a difference.
So the other question is from Mark, and it relates to Canary deployments. So the concept of deploying a new feature to a small percentage of users before agreeing that it's working well, and deploying to larger group and a larger group, like a progressive deployment, or to everybody, or agreeing that it's not going well and rolling back or redeploying. And Mark's question is like, how do you distinguish between a typical Canary deployment, more load balancing, and expanding from a small number of users to a larger set, and the agentic AI solutions with Cloud Canaries? Is it smarter load balance, or is it more AI observability? So I think it's a question about how we're defining things here, and also perhaps how Cloud Canaries help in a Canary deployment scenario.
Well, first of all, as far as in a Canary deployment scenario, Canaries are really great for running a group of Canaries, same Canaries, in a development environment through a beta deployment, especially in the cloud, and then in production, because you collect data for all kind of 3 areas, and so that certainly helps the learning of those Canaries to actually make broader decisions as far as what is broken and what is not, and how to fix it. So Canaries do that. As far as how broad the learning is versus how structured it might be, it only does a load balancing. I think to some extent that's going to be up to the customer. Because the goal is to actually have Canaries that learn. And sometimes it's going to learn things beyond the services that they actually provide, which might be making sure the load balancer is working. Or it's broad enough so that it says, well, the load balancer is actually just working just fine. It's your third-party backbone that's chopping up some of the data, and here's the reason for it. So I think it's important not to limit learning to a particular kind of vertical service, making sure the load balancer works, but keeping it broader so that you can look at these other issues. I mean, there's been so many situations where you think a service is down, it's really the endpoint works just fine. It's getting to it that actually is the problem.
Okay, let's go to the next slide and summarize this piece.
So again, Cloud Canaries can use our own internal neural networks. We can use Databricks. We can use Snowflake. And if there's other tool sets that a customer wants to use to generate their models, we can, depending what it is, we can probably take care of that. The whole integration of models and forecasts has taken into account that things change and vendors change, and we always want to be able to have the platform be able to use the best technology around.
Let's talk a bit then about forecasting and predictive AI. So predictive AI in some respects is nothing new. Supermarkets have been able to change their supply chains according to the weather and make sure there's more lettuce on the shelves in summer, and all sorts of applications of predictive AI have been around for a while. In terms of AI ops, we've always had this debate around predictive AI, and that if we're able to predict something is about to break, we should maybe have already fixed it, certainly if it's something that's happening repeatedly. And you referred to this earlier when you kind of said once the AI agent has fixed it and done it once, it will know to do it again. And hopefully it can give us an alert to tell us that there may be an ongoing problem or some technical debt in our systems we could resolve. But let's have a look at this in more detail. Let's talk, if you wouldn't mind talking us through this, Mark, and explaining to us what's different about our ability to forecast within an AI agent compared to what we've been doing before.
So I would claim the breadth of those learning and the decisions that can be made are really quite different. And with AI agents, agentic AI, it's much broader. And on-demand forecasting is great and it has its purpose, but it is really more vertical, smokestacked in nature. So it provides a broader capability. I do believe neural networks at the end of the day are better. And that's hard for some mathematicians and programmers to actually take into account, because there's, I call it the AI shrug, where you say, I have no idea how it came up with this decision to do this, but it was correct. And so you don't necessarily, it's hard to find that information. You can do it, but it's harder to find that information versus an on-demand system that basically it's really more obvious and really math. Well, they're all math driven, but at a higher level. But they're not necessarily as flexible, and they have value, but depending what the data is and how they're designed, they might not be able to solve all the problems. So neural networks, broad and deep as far as being able to learn and make decisions. Forecast demand, on-demand forecasting, good solutions, but not that. You're not going to have something that learns.
Okay, let's look at the last slide in the set then and talk about autonomous healing. And this will, I think, lead us back to the conversation we almost started about AI agents taking over and the security and risk elements of this and life in IT in general and ethics. So let's go to the next slide. And if you would talk us through this.
This is one of my favorite slides, the loop of how things are continually added. But I'm going to go to the next slide.
Sorry, had you finished everything you wanted to say?
Let me go back and just spend 30 seconds. The key here is that there's a process for building models for doing forecasting, and there's a piece of there's a validation aspect. And one of the keys within our system is to be able to provide the user a high level, a view of how well it's going. Is the data good? Is the model creation good? Or were there any errors? And then to actually look at the actual forecasts, because the forecast will drive everything. It'll drive the forecasted events, and ultimately the feedback for learning will be there. So this is a great slide that I think is we can talk about more at some point.
Well, let's do it quickly now, because actually I do have a question based on what you just said. If we go back to it just for a second. When we're talking about forecasting in the context of IT operations and observability, and in the context of Mark's question, are we forecasting event failures, trace failures, release failures? What kind of things would you typically forecast in that IT ops environment?
Events.
So we're expecting that to break at 5 p.m. on Friday, because we've seen the scale of this cloud instance tip over 80% or something.
Yes.
Okay.
It can also say, this system is running really well. It depends how you leverage it, where you set your thresholds, and how you want to leverage the data. So it's just as important to know when there's a potential negative event as to know that something's happening really well. Both aspects can be used for learning.
And what does the human AI interface looks like? So I think what I'm really asking there is when the AI agent picks up something that it thinks is interesting, or we've set the threshold for it to know that we want to know about it, does it send us an alert itself, or does it integrate with a sister ticketing system like ServiceNow or something? What happens there?
So it's going to do that if the customer wants it to. So we can interface, we can notify any ticketing system. Within our dashboards, we also want to show the workflow of that particular canary or that service, which is a library of potential libraries of multiple canaries working together, and look at that workflow and make a determination whether what it's learning is correct, and what's critical about it and what's not, and should we regenerate the model, or this is like a piece of gold that we're actually mining right now. So it is the dashboard that actually shows a canary or a group of canaries of the workflow of what they're doing and how they're making decisions.
Fabulous. Are we ready to go to the next slide and talk about things like...
Absolutely. I'm
Yeah.
losing my voice. I love it. So at the end of the, well, I always say at the end of the day, but there's three pieces. And one is kind of, I don't say old world, but it's more traditional observability. But I think it's important because this new world, we still have to solve problems. And so we can have the most sophisticated AI agentic agent canary, but if it solves new problems without maintaining solving the old problems or eliminating them in a way that humans don't have to deal with them, then we have failed. So predictive visibility, continuous monitoring, it's critical, because we're collecting data, well-cataloged data, and you continually, and that is invaluable as far as learning and knowing when things are going to happen, whatever they might be. SLA compliance kind of goes back to governance. You kind of have to manage that, because if it's not doing that, then how can you really say the forecast and what it's predicting or what it's doing, what it's learning is actually valid? Going back to a platform that has a large surface area, many solutions, single platform, it provides this very rich opportunity to make decisions and to learn. So autonomous remediation, there we go. And again, our ultimate goal is to have agents, canaries, that can respond within seconds to events. Now, it might just be an event that might happen months from now, or it might just be something just broke in this data center in Amsterdam, and my pops are being overloaded with data, and something has to change, like now, or you're going to have a very bad day. So, those are kind of the extremes that an agent can actually solve, predictable outcomes. And this kind of goes back to on-demand forecasting is pretty predictable. But so you have to maintain that, but you actually have to, every once in a while, something is going to happen that hasn't been predicted from kind of past patterns, and you have to catch that. Align actions with intent, do no harm. Ultimately, agents cannot do harm. And so I think that's pretty, I think we all understand that. The key with both these columns here is that ultimately the goal is to have a convergence of metrics. Because ultimately the cloud is a major portion of a business enterprise. And we have to connect the dots. And we generate all this information, have all this learning and intelligence. we have to connect the dots to what the business is doing. Where, how it's generating revenue and all of that. So connect the dots, predict anything, forecast anything, repair anything, and manage the cloud. So ultimately, I think this is the plug-in to business intelligence, providing decision makers a richer source of opportunities and ways to solve problems that they've never really had before.
We have about just over 10 minutes of our scheduled time remaining. I know this is our last slide. I think we could go in two directions from here. One, we can drill down a little bit more on the do no harm and the wider conversation about security, risk, and ethics. Or if you wanted to show the audience a quick demo, I'm sure they'd appreciate you perhaps showing them how it feels or looks to create a canary.
Sure. I'll create a canary, and then we probably have, because we can do it so quickly, we can talk about other things. So actually, I'm going to, can I just, Cloud Canaries, log in, you have an account, you log right in. If you're a developer, I think I'm an old developer, you see the canaries that you have that are running or that aren't running or that are healthy or new, and we'll take a quick look at that. But you also have some dashboards, health dashboard, compliance dashboard, forecast dashboard. And the way you create a canary is, so these are libraries of canaries that are loaded, that a user can load, and they're effective by the organization. So if you're in a different organization, you can have different canaries. You can also, an individual can be members of multiple organizations within that company. So I'm just going to pick internet. I'm pick my favorite thing, ping. I'm going to pick a type. So ping was this kind of library of canaries, and there's 4 canaries here. I'm going to put ping success. It's a secret. A lot of observability systems are based on ping. I'm going to pick a API key. I'm going to pick the region. It's going to be all regions, and then I'm going to name it ping. My typing ability is a little bit not as good as it normally is. So I'm just going to say ping 4.7, whatever that means. I'm going to say create. Now, it's actually disappeared. So I have to go back to new, and right there it is. So I'm going to edit it, and I'm going to give it a endpoint. And I'm not going to touch any of these other tabs. One, you can set thresholds for latency response data, and you can do the same thing for whether it's forecasted or not. I'm just going to save it. And give it tell where it's going to run. I'm not going to download it and execute it as a standalone executable. I'm just going to give it a cluster to run into. Now, these are our clusters. For an enterprise, that customer, they would have their own repository for the canaries to actually be executed from, so they wouldn't have to be pulling it from our SaaS product for security reasons. So now I actually have a cluster. I'm selected. I'm going to set a schedule up. It's running 7 days a week. I'm going to say, okay, test it. Do whatever you're supposed to do every 2 minutes. I'm going to apply that, and then I'm going to back here, and I'm going to start it. And you can certainly start, n number of canaries that you want. So it started, it's running. I'm going to go back and go to running canaries, and right there it is. It's running. We can take a look at it, but it's not going to have any data just yet, no data, but it will have within minutes. So as a side note here, we can look at, let's take a look at, this is a OpenTelemetry Canary. I didn't want to really create a new one because it's my copy and pasting would probably fail, but this is the environmental variables. We have latency thresholds that you can pick. We have response thresholds that you can pick. We can look at the forecast data, and we can also use that forecasted data for alarms and notifications by default. So that's pretty cool. And matter of fact, this is running. See, it's running. Yes, it's running. We can drill into it, look at the graphs. At some point, if you want to see a further demo, I can show you some of the new grafting capabilities that we have, but not right now. So I just created a Canary. It's running. This was just a couple minutes. Health dashboard, compliance dashboard, and a forecast. This is kind of a rolling 5-day forecast with weather reports, basically. It's kind of cool. Let's go back here. So that's kind of just a quick little, we've launched a Canary. We've looked at some of the dashboards. We haven't done a deep dive in the model creation, but we can do that another day.
Perfect. So quick. I think there's two elements to the security discussion that we can finish up with. And one, I do note that our demo environment is called Secure Compliance Inc. And we do have a tab for compliance. I think the two elements are on one side of it, and in your last slide, you talked about autonomous remediation and do no harm. I think, even though we're quite far into the AI hype cycles, particularly the Gen AI hype cycle, people are starting to believe less than the world's going to be taken over by AI, but there's still some fear. So one question to you is, how do you manage an AI agent implementation whilst allaying people's fear? So how do we teach people how to be safe when we're adopting AI agents? And then the next question is, how do we use those AI agents to make our business more secure?
I don't want to, again, I treat these agents like they're people, and that's really not, I'm not trying to do that in reality, but it's a good analogy. These agents are going to be able to learn, and instead of making the change, they can upfront just notify. There's a problem here, we can do this. There's a problem here, we can do that. And then at some point you take the training wheels off, because you've actually taken to the step where you know that the agent has learned enough to identify a potential issue, no matter whether it's happening right now or whether it's going to happen 6 months from now. You know what that agent's going to do as far as what the corrective actions would be right now. So you know that, and then the question is when do you turn it on? Those corrective actions. And to me, at the end of the day, it all boils down to cost benefit, and this also builds confidence. But the whole, if you have some major disaster, that major event that's happening in the data center, and if you ever looked at Grafana graphs, you can actually see the ripple effect, and you literally have seconds to react, or your database is going to be corrupted. So the simple, next thing is stop it. Stop that that database from loading data. So these are the things that have high value, that saves huge amounts of money. Production database can be literally millions of dollars for a day to fix, just because you're losing, the opportunity to find out where your merchandise is within your supply chain. So you can start there, and you can move on. There's always going to be guardrails within the Canary AI agent that will set guardrails up. There mean certain things it can't do. And that's going to be, again, a decision by the customers and the folks who are writing those Canary templates and populating them with data.
Wonderful. So we are nearing the end of our time. Thank you very much, Mark. I've put audience, I'd already put a link into the chat for the EMA, the Industry Research People EMA's report on us and our work with observability and open telemetry. And I've also put a link to a free trial in there as well. Cindy, I wondered if you wanted to say a few words about what we've covered today and what people could do next with us as well.
Yeah, so thanks, Helen. I just wanted to try to tie everything together, especially with respect to Charlie's question earlier. So when we say that, or when Mark says that here with the convergence of metrics, you can predict anything, forecast anything, repair anything. And this means that regardless of the size of the organization, the previous events they may not have ever had or had, that the system does give you the ability to create models for anything and the ability to remediate. So I think there's a lot of value in trying to wrap your head around the AI value and building models and being able to predict and prevent and remediate. So on that note, I know the attendees have a varied level of interest in how to apply agentic AI, cloud canaries. And I've left in the chat contact to feel free to contact us. We'd love to talk to you one-on-one about your needs, your interest in this space, and give you a personal demo, a customized demo. So thank you again.
Thank you, Cindy, and thank you, audience, for being with us today. We will send up a follow-up email with the on-demand version if you want to share that with any of your friends and family or colleagues, probably. And thank you, Mark, in particular, for sharing all of your knowledge today and showing us Cloud Canaries. See you somewhere sometime soon.
Thank you. My pleasure.
Thanks, everybody. Bye.
Bye for now.
Bye-bye.